So now we can see the free body diagram here. So we know that if we see this much part only, okay, so in this part on the left side force P is acting. So as we are moving next on socket as well as on spigot, force P is acting. So if I remove all these three parts and if I take the section of spigot and socket, I will get this as a free body diagram. So first of all we will only consider the socket, only we will consider the socket here. So in the socket we know that P and P by 2 and P by 2. So P is acting towards left side and P by 2 plus P by 2 is acting towards right side. So this part will be in equilibrium. So minus P and plus P will be in equilibrium. Similarly for Cotter, this P is acting at the center of the Cotter, and due to which opposite forces are acting on the other side of the Cotter, P by 2 and P by 2. Similarly this as force P which is acting on the center line of the spigot, and this is acting on the right side of the spigot, so they will get balanced. So you can see all the parts are in equilibrium now. Okay, fine. So let us see the different failures of the parts and their understanding. So we are going to see mode of failure of the component. So how many components are there? Three components are there. One is spigot, second one is the socket, and third one is the Cotter. So how they are going to fail, their mode of failure, then which area will undergo failure or which part undergoes failure, its diagram, and last one is the stress equation. So while doing this stress equation, we have to always consider the fundamental equation of the stress, that is force upon area. So force is P and area is nothing but the area which undergoes failure. Suppose a tensile force is there, okay, then due to which tensile failure will take place. So for that sigma T, tensile stress is equal to tension T upon area under tension. Okay, so in this way, so basic equation of the stress will be, the basic equation of the stress will be force upon area. So first we'll see the tensile failures of the rods. Okay, so its equation is very simple. We know that sigma T is equal to P upon pi by 4 d square, where d is the diameter of rod. Okay, therefore we can easily reshuffle the term and we can find out what the d is. D is equal to under root 4p upon pi sigma t, or you can keep this equation as it is. As it is. Okay, so we can find out the failure of the rod. Next is tensile failure of the spigot. Okay, so let us see the diagram here. So in the diagram I have shown the spigot. So if I take the section here, okay, so we will get the area under tension. Now one can say, sir, we are getting this area also and we are getting this area also, but as far as your design is concerned, we have to design for the weakest cross section. So where is the weakest cross section? The area of the cross section is least. So where is the cross section area is the least? You can see this shaded portion here. In this shaded portion, the area of socket, area of the spigot is very less, or we can say spigot of area of the spigot, cross section area of the spigot is least. So this area we are going to consider. So you can see this diagram here now. This one is total spigot. Okay, this one is spigot. So in this spigot, XX is the section which is having least cross section. Okay. So what will be my equation? Equation will be very simple. Area at section XX. So what is the area at section XX? So one can see the total area of the circle is pi by 4 d square. From that we have to subtract the area of the slot. Okay, so I will zoom here. So what is my section, cross section? This cross section will be total cross section pi by 4 d square minus d2t. Why d2t? Because d2 is the height and t is the width. So d2 into t will be the area of this rectangle. Okay, so we have to reduce this area of the rectangle to get the cross section area. And what is the formula for stress? Sigma t is equal to P upon area at section AA. So we are getting sigma t is equal to P upon pi by 4 d2 square minus d2t, where sigma t is tensile stress. where sigma t is tensile stress. Okay, so here if we are having value t, okay, if we are having value t, so how much is the value of t? T is equal to 0.31 times into 0.31 times into d. This is the thickness of the, this is small t, okay, this is thickness small t, thickness of the quarter, or we can say thickness of the slot. Okay, so here pi by 4 d2 square minus d2 into t. So here I have to find out d2, and t is equal to 0.31 t. But in previous table, or in previous row, I have found out the value of d. D is equal to 4 pi upon pi sigma t. So I can put d here, I will get t, and I will put t here. So I will get p is equal to pi by 4 d2 square minus d2 into t, 0.31 d. So here d2 is unknown only, I can find out the value of d2. Next is tensile failure of the socket. Shows the weakest